So, Chapter 5 is complete. On to Chapter 6, which deals with parallelograms. Parallelograms, keep it very general, but we're going to start general. We're going to work our way towards parallelogram here at the beginning. As I said, you already have the notes on there, but you might still want to write something. A polygon is a closed figure with 3 or more sides. Okay. And we should probably even add in there that the sides or the parts of it should be segments. You don't want to have arcs and things like that in there. All right. For example, we should not consider that a polygon. Right? So we should say there should be segments, because sides are considered to be segments. You might want to add that little note in there. A quadrilateral. Is a quadrilateral a type of polygon? What do you think? Should a quadrilateral be a closed figure with segments? It should, right? And what's the only criteria that we have to add then? 4 sides. Very good. Okay. So a 4-sided polygon. Okay. Does it have to look perfect? Could we have a little one, and then one there, and then one over here, and then one like that? Does that count? Yeah, that would count, right? It doesn't have to be perfect or symmetric or anything like that. It just has to have basically 4 sides and be closed. Realize this word tells you that all of that stuff has to happen up there, right? When they use that, they're saying that you need to use all of that. So here are some examples of quadrilaterals. Do you agree that all 3 of those would count as quadrilaterals? Or have I been testing you here to see if you can figure out which one's not a quadrilateral, or are they all good? Yep, they're all good. Yep. 4-sided, they're closed, they're segments, we're good. Now, are these actually all examples of non-quadrilaterals? Yes. Okay, so what is the reason for this first one? Why is that not a quadrilateral? Yes. Yeah, not closed, right? Okay, so, and then some people even look at that it's a kind of an optical illusion. People have told me that's not a quadrilateral because it has 5 sides. And if you look at it quickly, doesn't it seem like it has 5? But if you count, it's 1, 2, 3, 4. But if you look fast, some people have told me in the past that it has 5 sides. Obviously, that would also be bad, right? That would make it a non-quadrilateral if it had 5 sides. How about the second one? Yeah, it's not closed, right? It's missing. It's not quite there. Obviously, if I extend those 2, that would work, right? And how about the last one? It's closed, but they're not all sides, right? Remember, what's a side have to be? It has to be a segment, okay? And so that's why that one. So, yep, I wasn't trying to trick you. That's actually the way that it is. Remember, always keep that in mind. I'm always testing you one way or another. So we started with what? Polygon. Then we said quadrilateral, right? Now we're going to say parallelogram, and that's really what we're heading towards in this particular chapter anyways. And do you also have that definition in there or no? Wow, you guys are lucky today. A quadrilateral, so it has to have how many sides? 4. Now, how come they don't say it has to be a polygon in this one? How come they don't have to say that? Yeah, they already said it has to be a quadrilateral, right? And that means it has to be a polygon, and it has to be 4 sides. But now we're adding more criteria, okay, where both pairs of opposite sides are parallel. So let's just draw a picture of that. Maybe off to the side, a picture will be helpful. Is that a quadrilateral for sure? That's 4 sides, right? We'll go with that. Is it a parallelogram for sure? No, because have I done anything to address this? What does it mean by both pairs? That's kind of a weird way to say it, isn't it? Well, that means that this pair is parallel, right? And that pair is parallel. Notice how I went with 2 marks on those other ones, because if I put all 1, then I'd be saying all 4 of them are parallel, and I think we know that's not true in this one. So that is basically a parallelogram for you. And I tried to draw it as good as I can. I think that top one and bottom one, they are parallel, and the right one and left one are actually parallel. So again, we started with polygon, got more specific, said quadrilateral, even more specific parallelogram. So of the ones that you see on the smartboard, A, B, and C, which ones would you say are parallelograms? Again, you have to listen to what I said. Yeah, I said on the smartboard. None. On your notes, do you have any? How come on your notes you have some that are, and up here there are some that are not? Yes? Yeah, I haven't put any parallel marks up here, have I? I think they might actually be in there, though. Maybe not. All right. So I believe, what did I put here? 1 here, right? And 1 here, and then 2 and 2. So let's do the checklist. Is it a polygon? Quadrilateral? And our opposite sides parallel? Yeah, we're good. Did I put any parallel marks on B for you? No, I did not. So can we say that that one is a parallelogram? Could we say it's a quadrilateral? Yeah, we could, but this one's asking about parallelogram, right? Could we say it's a polygon? Letter B. Yeah, okay. I'm trying to get you have these words in your head. And then you told me this one also is a parallelogram on your notes, because I believe I did this, correct? And so then, yes, those would be good. This one, no. So once again, try and think, how could he ask the question differently? For example, if I asked which ones of these are polygons, you would have said all of them, right? If I would have said which ones are quadrilaterals, you would have said all of them. And so the key here was I was asking about parallelograms. When naming a parallelogram or any quadrilateral for that matter, you got to go around the figure in some type of order. Okay? You can't just jump all over the place. And there's only 4 of them, right? So you might as well at least just pick somewhere to start and then kind of keep going around. And once again, mathematicians a little bit on the lazy side, and so we just kind of put something like that out front. And then you just pick some place to start. Where would you like to start? W, X, Z, or Y? Start at Z. Okay, so we're going to start here, so we're going to put Z down. What you have to do is decide, do I want to go around the figure going this way, or would I prefer to go around the figure that way? It does not matter. You have to just choose which one you want. And if I were to say to go around the figure clockwise, what should be the next letter? Or is it the red or the green? I could ask it either way. Which way is clockwise? Red, right? You can always look up there. Which way is it going? All right? And so, yeah, you would go to Y. And then if I'm still going clockwise, I would go that way, W, right? And then X. Is that the only correct answer? Well, in fact, there's a lot of ways of answering this. But notice how I used all the letters. If you think of a quadrilateral, if I just use 3 of the letters, is that enough? No, because maybe there's this in there, right? Then if you just give me Z, Y, W, you could be talking about the triangle, right? I wouldn't know necessarily. Okay, so use all the letters as you go around. Okay. Any questions on that? So again, I could have gone counterclockwise. That would be the green one, and it would be Z, X, W, Y if we start at Z. Any questions so far? All right. This is pretty important. You should probably know these. Maybe make flashcards for yourself or something. Both pairs of opposite sides of a parallelogram are congruent. Well, what's one thing we already knew on all of these? If this is a parallelogram, don't we already know that that's parallel to that and that's parallel to that? And how do we know that? That's because it's the definition of parallelogram, right? So what is this adding in there? And I put those on there for you, didn't I? Yeah. Well, mine are a little different. You get the idea. What? Yeah, how do we mark that again? Yeah, little notches or something like that. So you put a mark there and there, and a mark there and there. See how they mean different things? If we have a parallelogram and we know we have a parallelogram, that has to be true. So in other words, if this one over here is 5, this one over here is 5. And if this one is 7, this one is 7, right? That has to be true. Okay, that's what that means. Well, let's put those marks in again, right? I think I put 2 on top and bottom for you, didn't I? And then 1 here. So we know not only will they be parallel, those sides, they will also be congruent. And what are we going to learn here? We're going to learn that the opposite angles of a parallelogram are congruent. Opposite angles. What does that mean? Yes. I like how she said that, too. The top right will be congruent to the bottom left, correct? Are we guaranteed that the top left will be the exact same measure as say, these other ones I just put in blue? Could it be? Could be. I mean, they could all be 90, right? Okay. But we do know that this one up on the top left must be congruent to the one on the bottom right. Okay. So not only do we know a parallelogram, the top or the opposite ones are parallel, the opposite sides are also congruent. the opposite angles are also congruent. So what that means is, let's say this one here is 80 degrees, then this one up here is 80 degrees. Okay, that's what that means. Okay? And we actually know what the other one has to be too, but we're going to learn that one in a second. Okay, so that's what that means. Better put those marks in again, huh? Because really, if I don't put those marks in, do we know it's a parallelogram? No, we don't, so don't make those assumptions, right? Consecutive angles are, whoa, there's some big words here. Consecutive angles are supplementary. Well, let's break it down. Let's figure out what each word means. Consecutive. They're not opposite. They're consecutive. So what does that mean, really? Yeah. Yeah, they're kind of connected by a side. Or if you want to go way back to what we were learning, here's your parallel lines cut by a transversal. Right? Weren't those supplementary before? Shouldn't they still be supplementary now? Yeah. And same thing over here, because these, what were these called before? They were called consecutive interior, right? Now we just call them consecutive because we're not talking about necessarily parallel lines and a transversal. We're just saying, let's look here. And so what we know is basically, we'll call it angle 1 and angle 2 have to add together to be how much? 180. Angle 3 and angle 4 must add together to be 180. Now, is that something you could write on your notes? Put a 1, 2, 3, and 4 in there, and right off to the side, 1 plus 2 has to be 180. 3 plus 4 has to be 180. What other pairs have to add to 180? Have to. Not could, but have to. I said 1 and 2, 3, and 4. Yes? Yeah, aren't 1 and 3 also, if you just turn your head, or turn your paper, whichever one's easy. 1 and 3, aren't they also consecutive? 2 and 4 are also consecutive, so they have to add to 180. So let's go and take a look at that. For example, if this one is 80 degrees, like in that last problem, what does angle 4 have to be? 100. What does angle 3 have to be? It has to be 80 for 2 reasons, because 3 and 4 are supplementary, and 2 and 3 are supposed to be, from the one we just did, 2 and 3 are supposed to be congruent. So this one has to be 100. You see how that all works? So 1 and 4 have to be congruent, 1 and 2 supplementary, all of these patterns that we already talked about, really. What else do we got here? Ooh, this is a big one. Most people forget about this one. Diagonals of a parallelogram bisect each other. Well, we know what bisect means, right? It means cuts in half. Well, what is a diagonal? Well, a diagonal basically means go from the top left to the bottom right and basically make a segment, right? And then there's, well, how many diagonals does this one have then, if that's basically what a diagonal means? Yeah, it has 2, right? I have to go then from bottom left to top right. So this one's pretty big. You might want to, highlight this one, or it's most forgotten, I should say. And what that means is if they bisect each other, this green one is cutting the blue one in half. So this is the same as that, right? And the blue one is cutting the green one in half. So it means that. I guess you would look at this as kind of something that you didn't really know before. We knew kind of all this other stuff before, didn't we? Yeah. Not necessarily. Okay, the question there was a great question. And would the blue line be the same as the green line? And not necessarily. But could it be? What would that figure be? A square for definitely, or at a very minimum, a rectangle, right? Look at this as a rectangle that's kind of been pushed over a little bit. The top of it's been pushed a little bit. And so you see how the blue one here, I think we can agree by looking at this. I know that's dangerous, but the blue one here would be longer because the points are further from each other. And by pushing that top, I kind of made the 2 green dots closer to each other by pushing it. Okay, great question. And so if I told you this one here was 10, would you be able to tell me how long the blue one was? How long is the blue one? 20, right? Okay. Or if I told you, this one over here was maybe 6 or something like that, well, you could tell me this one over there was also 6, right? So keep that in mind. But you can only do these things if you know what you're looking at is a parallelogram. Okay? So any questions on any of these that we looked at? Again, some of these you already knew, right? That one, circle it or something. All right. So determine the value of A, B, and C and D, excuse me, in the following figure. Now, what I tried to do for D there is D is that entire angle there. You see how I tried to put a little mark on it? D is all of that. All right. Now, some people are saying, why didn't you just say angle E? Well, angle E has 3 possibilities, right? And so I couldn't just say that, and I was way too lazy to say, like, you know, DEF. So I just threw a little D in there because I was a little lazy. Do any of them seem easier than others? Well, actually, as of right now, how many can I answer on the smartboard? None of them. How come I can answer none of them on the smartboard? Yes. I don't know this thing's a parallelogram. But do you? On your paper? Yes, you do, because you have the marks on there, correct? You have this one, I think, and this one, right? And then this parallel to that one. So you can actually do this. I was unable to up here. So does anybody, just by looking at it, think they can tell me A, B, C, or D? Any of them? Yes. How do you know that A is 10? Based on what we learned earlier, which one helps you know that A is 10? Yeah, the diagonal one, which is what, number 4, was it? Is that what it was? The 4th one, right? It'd be really that one, right? So we know that if this is a parallelogram, that has to be congruent to that, right? And so A better be 10. And we would say based on number 4, if I were to ask you to justify, right? Yes. What do you got? Okay, I've been told that B equals 35 degrees. I happen to agree. That actually I thought was going to be the hardest one. How did we come up with that one? Anybody, can you explain how you got that? Yeah. Yeah, not quite bisects, but if we do this, it's a parallel line, transversal. 35 and B are close. Alternate interior angles. We already learned that those have to be, remember, look for that like Z type shape, right? Okay, and so B does have to be 35. Very well done. All right, let's get this red out of here so we can actually see what's going on. We'll leave that there. No, we'll erase it. It just looks bad. We'll put it back in. There we go. Remember, D's all of that. All right, with that being said, does anybody believe they can help me with either C or D? Yes. I've been told that D is 125 degrees. Well, I don't even see that number up here. How did you come to 125 when the number is not even in the picture? Okay, very good. What I was told was that basically this angle down here is how much altogether? 55, correct? And 55 and all of this up here have to be supplementary, correct? And if 55 of the 100, that's what supplementary means, 180, right? If 55 has been used up, are we left with 125? Yes. Did I very much not draw that to scale to try and throw you off? Yes, I did. This 55 down here, in fact, it would probably look better if the two were switched, right? That would look probably more accurate. Yes, D is most definitely 125. Good job. I would say that might have been maybe that second hardest one. Yes. And how did you come to that? Yep, very good. Basically what it came down to be is if we know it's a parallelogram, that better be the same as that one up there. Notice I used 2 marks just because I used 1 earlier. All right, that's the only reason. We know that 16's down here, and I could basically put 16 up there then if I felt like it, and 16 and 4C are occupying the same spot, and so they better be equal. And I think most of us just knew 4 right away, right? We didn't actually do the algebra, but there it is if you want to see it. And so C is most definitely 4. So I think we used a lot of the information that we just learned to be able to solve this. Very well done. Are there any questions about how we came to any of them? Because the way that you were told by the people that got it are not the only way, but probably the quickest ways. Okay. Very good. And I don't even have something else, but on here there is something else. So if I gave, and we're just going to talk about strategies here. The question is, on the notes, is if I gave you a bunch of points, say, it is on there still, right? Yeah, okay. R is 1, 1, S is 3, 6, T is 8, 8, and V is 6, 3. We're just going to talk strategies really quick. What if I was to ask you to find out if that was a parallelogram or not when you connected those points? What would be some good strategies to start with? We're not actually going to do it. We're just going to talk about how you would do it. Yeah. You think graphing those 4 points might be helpful? Probably, because let's face it, it'd be very simple. If you get a point like here, 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 and there, you're pretty sure that's not going to be a parallelogram, right? Or if you end up with something that just is very bizarre, like maybe here, 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 and here, that's not going to be a parallelogram. Is it going to be quadrilateral? Yeah, but not a parallelogram, right? So very simple sometimes to tell. But what if you get a bunch that are somewhat close? Agree that has the chance, right? Now, how would you tell then? How would you go about figuring out, is it actually? Okay, well, that looks terrible, but you get the idea. Yeah. Yeah, you could find distance, right? We have distance formula, and if that ends up being the same as that, and that's the same as that, are we probably doing pretty good? Probably pretty good, right? What's another way you could test? What's another strategy? Maybe a little shorter than distance formula. Slope. Why would you use slope? I need to find out if that one there is parallel to that one, right? So they better have the same slope. And this one has to be the same as that one, so they better have the same slope. Okay, very good strategies. Does anybody have any other ones other than ask me? Okay, so kind of a distance formula idea. It's kind of almost the slope and distance formula together is what you're saying. Yep. Kind of the picture way we did it, right? With putting the, get there. How would you get from one point to the other and see if they match? Yeah, it's kind of the two put together. Anything else? I think those are pretty good strategies. That's a good start. Do you have any other questions?